And here we go. All right, so today we're going to talk about something called a stack. Next week, we're going to talk about something called a queue. And then I believe our test is shortly after that. And we're just moving right along. And I think we introduce a new topic before we then have our test, which is up through stacks and queues. So, stacks and queues are similar. And we're going to start with a stack today. Like I said, queues next week. But we're going to say, okay, here's a stack. How would I do this if I was working with it in terms of an array? How would I do this if I was working with it in terms of a linked list? Which one is more efficient? Then I give you the code. Like here's your header file and your implementation file for the linked list. And here's the same thing for the array. And I'm boring myself, so I'm sure I'm boring you. Let's get to it and see what we got. So, what is a stack? Bow, pow, 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 pow. Let me switch my camera over to here. Let me change my view to speaker. And we got this. So, we have stacks. Today, we're going to take a look at, and this is Gaddis 19.1 to 19.3 to start. And at the end of class, we're going to switch over to the NIAF book and look at some applications of how we can use a stack. So first of all, what's a stack? Well, there's a bunch of different ways to describe a stack, and some of them are like a Pez dispenser. I have to be careful. Some people don't know what a Pez dispenser is, but you put one in and then you push it down, and then you can put another one in and push it down. Put a gun clip. I don't know if any of you are hunters or just avid shooters. A stack of plates in your cabinet. Like as you wash one, you put it in, you wash another one, you put it in, you wash another one, you put it in. So all of a sudden you have a plate, and then you have another plate, and then another plate, and another plate, and that's an awful drawing. But you start to build up this stack. Okay, well, how's this work? Well, this works this way. The last in is the first out. And this is this world of this thing called LIFO, here referred to many times as LIFO. All right. So what are we going to do? Well, we're going to think of our memory this time. Instead of our array, we're just going to start with arrays, where we have it that looks like this. We're now going to turn the array, instead of horizontally, we want to look at it vertically. And we now have an array, and this is just for thinking. I mean, it's not like we can now program an array to go a different way, but this is just for thinking purposes. And again, it'd be like turning this. This is zero location. This is zero location. Okay, so I took this horizontal array and made vertical to give me this idea of a stack. And let's say I want to put numbers in a stack, right? We're working with a list. First number I'm going to put is a 5. So when I get ready, like a plate, it goes on the bottom. The next number is an 11. It goes above it. So I keep building these numbers into this list that is laid out this way. Now, since they keep piling up on top, what would be the first? Well, the first one that I take out of here is going to be the last one that was in. That's going to be this 7. So I'm going to come up with 2 words to help us do this. And the first word is push. I'm going to push a 5 onto the stack. I'm going to push an 11 onto the stack. I'm going to push a 7 onto the stack. And now I'm going to use a word called pop, which then will take the 7 and pop it out. Okay, so I'm going to think of a stack as a class. I'm going to think of a stack as a class. I'm looking at it as an array right now, an array implementation to it. I'm going to need two new functions. One's called push and one's called pop. So let's redo this again. Let's knock it back down. And when I followed these steps, I put in the first, I pushed a 5, then I pushed a 7, an 11, then I pushed a 7, and then I pop. Good, got it. When I add to the end. When I pop, when I delete from the end. Last one in, I keep adding to the end, is going to be the first one out. Again, think of it as a stack setup. What do you think? I got my whole array done. Yeah, my array, we know that's a fixed size. We called that static. We already just made notes. We said we're going to add to the end, which is my push, and we're going to delete from the end. That was my pop. Oh, I can dig it. Still working with a stack. Same idea. Last one in is the first one out. Again, we thought of a stack of plates. We built this array. The last one in is the first one out. Now, just think that the last one in is the first one out. Because what I'm going to now take a look at is what if I have a linked list? And again, we know that this is dynamic, it changes. Right now, I have head and it points to null. And I'm going to create a node. Okay. So head is now going to get the value of the new node. That's that whole if it's empty head. Oh man, there's a whole bunch of code that's going to come with this. But if I put in the first one was a 5, and that goes to null. Now, I need to make sure I am following last in is the first out. My next node is 11. I need to figure out where I want to put that node because I have two choices, right? I have two choices. What do you think? Do I put it in front of the 5? Do I put it after the 5?
Wouldn't you put it in front of the 5?
I have a suggestion of in front. You asked me the question. I don't know why. Nicodemus, wouldn't you do this? Well, I'm asking you, where do you want me to put it? So you answered my question with a question.
Well, if you're trying to do the first one or the last one in is the first one out, then wouldn't you want to put it in front so that your older one is further down the stack?
Because if I would add it to the end, and I don't want you to confuse it like we were doing with the array. When we added it, we kept adding to the end because I had to. I could have added to the beginning, but what would I have had to do if I added to the beginning?
You would have had to push everything else back.
Yeah, everything would have had to be shifted. So by adding to the end, I know what this location is. I keep track of it. I can just go and grab this location. If I tried to add to the end here, I don't know where the end is. If I had 1,000 pieces of data, I'd have to go to all the way out to holy camolies to add it. And then when I got ready to delete it, I'd have to go all the way out there to delete it as well. So for this, and when I get ready and I add push the 11, I'm now going to insert it here. So I'm going to create that new node, 11. Oh, wait, I'm building an algorithm here because I'm drawing the picture. This is cool. When I get that new node, then I'm going to say this guy gets the value of this pointer right now is at null. What's the next step? This guy's pointer gets the value of what?
Or the value of 5.
Yeah, it gets the value of this. It gets the value of head. So now I have something that looks like 11 points to what head pointed to, which was 5. I'm building code as I do this, right? Once I do that, what's the last thing I'd have to do?
Update it so
Uh,
that the head is pointing to 11.
Yeah, head now gets the value of new node. Head now gets it. Oh man, I should have written that down, right? I have a new node. I created a new node. And then I said something along the line of new nodes next got the value of new nodes next right here. I want it to point to what address?
Point it to, or have it set to the head's pointer.
Yep. I want it to point to where head was pointing. And then I said, okay, good. Now I want head to get the address of
Of new node.
new node. Good. So in my world of notes, this helps me, these two lines help me insert at beginning. Uh, I create a new node. I put it at the beginning by saying it gets where head's pointing to, then head points to that node. There's the drawing of it. Create a new node. We said it now points to where head was pointing, which was that node that contained 5. Huh. How would I delete? How would I pop? This is now, oh, okay. We're using terminology here. This is how I'm going to push. How am I going to pop? I want to get rid of 11. What would I do?
I think point head to 5.
Okay. Yeah. I want head to now point to 5. Head gets the value of, let's see how clever you are here. Head gets the value of, this is an
New node
address.
next.
Say again.
New node next.
Well, what if we're popping like 5 straight times? We don't really know what new node is. What do you think? What is this node also called? What is this guy right here called? What was this guy's? This guy's, we had the word next come into play. Head gets the
Next
value.
next.
Head's next. Good. Again, you're now into a learning where I can't write this stuff, or I can't write the code. I have to write bits and pieces of all this by drawing a picture and making it make sense. I got to do all of that first. Okay, so we have stacks. We have an array and we have a linked list. Some of the thinking we were doing in a linked list was, how do I push? How do I pop? Just wrote a couple of lines of code to get started there. I'm going to put you in two groups because I want to know how you would push and how you would pop here on the array. Just a couple of lines of code. I want to see what you come up with. What do we want to call the array? What information will I need coming in? I mean, I needed to know head. I needed to know new node, a couple of those things. What will I need up here?
Wouldn't you need to know the array size and what you're trying to pop or push?
Okay. So we'll have an array num. And we need array size. We can just call it size. We could call it array size if we want. So start thinking of, before I write this, I knew I was putting it in the beginning. This was easy. If there weren't any, fine. I don't think that changing push at all. If there, pop, we could check is empty. How do you know if it's empty? Head equals null. But is there a little bit more code to doing this than there was to this? For example, what if my size is size of the array or size? So size, is that the size of array? That's fine. So we might need to know the size of array. What's another thing we're going to need to know?
How many objects are currently in the array?
Yeah, let's call that num l elms, number of elms. And I think the number of elms is going to affect what we put for our push and pop. What if the number of elements equals 0, 1, 5? We want to make sure our code works for all of those. But so again, we're doing a lot of this. Before I can start writing code, this is my test data. What if? What if? What if the number of elements is 10 and I try to push? Oh, it's full, can't add anything. Okay, so I'm going to put you in two breakout rooms. There's a whiteboard you can use in your breakout rooms if you want to do that. You want to start to write some things down. So I'm going to pause the recording, which you're going to remind me when we come back to start it again. So I'm writing the code for push. If else, if else. This is taken care of if it's empty. This is taken care of if it's full. Otherwise, what do I do? Again, this is pseudocode. This is algorithm. I know what I mean by display full. That means I have to do some kind of messages that say, hey, the array is full. We can't add anything else to it, yada, yada, yada. The number of elements is 0, right? I have number of, and I have to keep drawing arrays so I can look at them. The number of elements is 0. I add 1 to number of elements and I put it in num array sub 0. I put that value in. Else, if number of elements equals array size, then I'm going to have some kind of message that says it's full. Else, so let's see, I have 3 elements right now. If I want to add a new one, it's going to go at location 3. So whatever that value is that's being passed in my function header is now going to be added to sub 3, because that's what, no, see, I needed to do this because of the -1 +1s and all that. And then I added, so at sub 3 is that new value, 6, and I change this to 4. I like it. Comments? My bet would be we were getting started. We were just a little slow to get started, but we were headed that direction. Does that sound about right? Black says, hell no. I mean, heck no. Black, you understand what's going on?
It was going slow for
Okay.
us.
But do you think your group was headed in this direction?
Mm, I think so.
Do you understand what's going on here now?
Yes.
Yes. Okay. Remember, with arrays, we were adding to the end and deleting from the end. Hmm. Next week, when we do queues, it's going to be different. We're going to have to take a look at how queues work with arrays and then with. All right. So that was my push. Nat, you okay with push?
Yes, I'm good.
Okay. Did we push it real good, Joseph? Push it real good. He shook his head. He's not, yeah. All right. What if I wanted to pop? Again, the first thing I did was draw an array, right? If it's empty, that was one of my cases. Hey, there's nothing to pop. I need to. So again, my pseudocode. Now return the value at, so here's three elements, and I want to return this value that is at 2. So I return the value at num element minus 1. My array, what did I call this? Num array. I didn't put it in there right away because it's easy to add back. I knew how to return the value at num array sub num elements minus 1. Then I need to change num elements because there's only 2 left. Okay. Now there's a 9 sitting here. I know there's only 2 elements now. Num elements now became 2, the 4 and the 8. Do I need to worry? Do we care if it's still there? For today, no, we don't care. Down the road, we're going to have to care. You'll see that when we get to some other stuff. Whew, another data type down the road. Right now, stacks is a data type. It's a data type. Queues are going to be a data type. Okay. We don't really care that's there. We care that there's 2 elements and we start at the front. So 4 and 8 are what are important. We're just going to keep that in mind for later. Okay. Questions. Again, I'm writing little blocks of code. I'm drawing the picture. I'm doing variable list. Num elements is 2. I needed to keep track of what that is, and I need to keep track of size of the array and so on. Okay. So we're going to look at 2 things. The first one is called int stack. Int stack is going to work with arrays. Works with arrays. And it's going to work on stacks, just like we talked about. In a minute, we're going to see a different one that's going to be called dyne for dynamic int stack. That one's going to work with linked list. Okay, that one's going to work with the linked list. So we have 2 new classes. One is arrays to perform stack operation. The other one is, so here we go. We come in and shooby dooby doo. We have some stack size. We have the top, which is also the front. We also call this the number of elements kind of deal. I have a constructor. Okay. Brings a number in, gets the party started if I want. I have a copy constructor. Okay. I did const, so I make sure I don't screw it up. Well, here we go. We now have, instead of insert and delete, this is the new insert. Push is the new insert. Pop is the new delete. Remember, we said every time we learn about a data type, we're going to have these basic operations. So really, let's see if our push and our pop look like that stuff I wrote up. All right, here's the copy constructor. We're going to have to go through the array and copy everything one at a time. That's like that deep copying. Here's the destructor that says delete that array. I'm done with it. It's gone. Again, we don't use this or think about it too much, but it's freeing up memory and it becomes kind of important. Here's pop, or excuse me. Come on, camera. Here's push. First thing I say, I can't add anything. That's what I did. Otherwise, this is what we called num elements, and we added it to the end. They didn't even have to check to see if it was empty to add it to the first one because this takes care of that. This takes care of that. What I'm saying is when I did it here, num elements and num elements. Num elements is 0. That's the same thing, 0. Num elements. So that first and third case were the same. Cool. Can keep it a little simpler. Nice. Let's see if the pop looks the same. Pops. Pop. Oh, check this out. We have a void. We're not returning anything. But what did I do here? I made an R word. Reference variable. It's a reference variable so I can return this num. So when I come in here and pop it off, same thing we did. Is it empty? Boom. Otherwise, I go and find it. I subtract 1 from top, but instead of a return statement, I return it in a reference variable. I like it. I love it. I want some more of it. Adam's falling asleep. Keep awake, Adam. I gave you all the files for chapter 19. Here's an example program. We do some pushing. We do some popping. We got a bunch of stuff going on there. Demo program for it. Quickly jumping over to Dooby-dooby-doo. Here's another example program. Math Stack. What? Math Stack is pretty cool. I want you to go to the file that's available, all the chapter 19 information. It's on D2L. Download it, and I want you to do MathStack. Load mathstack.h, mathstack.cpp, and program 19.2. Uses the same thing, but it's pushing and popping values and adding and subtracting them. It's kind of a cool application. Math stack. Math stack. What are we doing with math stack? Check out math stack. Line 6. Line 6. This is powerful. What is it doing here? Math stack is using int stack. It includes int stack. So in math stack, I have add and subtract, but because I'm friends with int stack, I have int stacks push and pop and is full and is empty. Folks, we're getting into heavy stuff here. You're going to see a pattern though as we keep going. Yeah, check that out. That's nice. When I add, oh, what's going to happen when I add? Add does a pop, pops the first two values off the stack, adds them together, and pushes it back on. If I had a stack, and up here I have 4, I have 7, okay, and they're up there at the top. I'm going to pop 4, pop 7, add them together, push 11. So my new one would be yada, 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 yada. There's a blank one. Now there's 11 and more yada, yada, yada. And subtract's going to work the same way. So an application of int stack. See, this is why I like when your cameras are on. I can see everybody's eyes are still in their computer. You're still getting it to work. Can I get a thumbs up when it works? Yep. Thanks, Joseph. That's nice. I'm using all of this work that's already done. Nice. This is definitely something you may have to come back and get your brain straight about. Okay. The next thing it's in here, we kind of mentioned it before. It's a template class. Do I want to use stacks, arrays, but this will let me use it for integers, for doubles, for chars, for whatever I want to use. So the template's also included in the files that you downloaded. And let's get to the next thing. Dynamic stacks, right? This is my linked list. You have this available to use in those 19 downloads. Again, this time the dynamic means we're using linked list. Let's see what we got here. We have push and pop. Pushing a value in. Again, we're returning a reference variable. We have is empty. I bet that's something like this head or top or whatever they call it. Point to null. Let's see if they look anything like we have. Oh boy. I have create a new node, fill a new node. These lines go together. I'm getting ready to push. I get that new node ready. If it's empty, top goes to new node. Oh yeah, we did that. New node's next. Well, it should point the null pointer up here, so that should be done ahead of time. We do the value and we should do the new node. Okay. Otherwise, new node's next. We called this head. Gets the value of head. Head goes to new node. Yes. When we did it right. When I first looked at this block of code, when I turned the page on, oh boy, what all is going on in there? When I break it down, I got it. I got it. Arrays. Oh boy. We are again getting from the beginning. If it's empty, there's nothing to get. Otherwise, yep, boom. Num gets top's value. That's right in the front. Oh, I have a temp pointer that points to the rest of my linked list because I want to free up that memory space and delete that node. Ooh. I need to draw it just to be safe. Let's see, they're calling it top. Top points to here. Num gets the value of 4. Num gets the value of 4. Temp gets the value of top's next. So temp now points to here. Delete top. Boom. I delete that. Top now gets the value of temp. Okay. Drawing the picture helps me walk through these lines of code. Good concepts. Good concept. Now, if you want, here's a practice. This number 7. Could I add more functions? Well, this is saying, all right, go to the linked list one. And we're not doing this, by the way. If you want to practice on your own because you have a whole week, here's a practice. What if I wrote a function called multiply? We saw add and sum, but that was for int stack, not dynamic int stack. What if I wanted to do a mult, where in this guy, it takes the top 2 from my linked list, multiply them together, and make that my new first value? Oh. Could I do divide? Could I do add all, which pops everything out of that linked list, adds them all together, and makes that my one and only element? Lots of stuff. If you wanted to practice and become really good at this stuff, that's what you would be doing. Okay. Again, this is dyn int stack. So just different things that you could do to mess around. We're going to look at a different application though today. Okay. Paper. All right. So from the NIOP book, let me get this so I can see what I'm doing. From the NIOP book, we're going to look at a couple of things that can be done by using a stack. It becomes pretty cool, right? The first thing we're going to do is convert from base 10 to base 2. Now, you may have done this in another class. You may have done it by hand. You may have done it by hard coding it. But what we're going to do is this. We're going to take 23 in base 10. And what does it equal? Digit, 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 whatever, in base 2. What does it? Okay. So here's how we're going to do it. We're going to go 2, and we're going to divide 23 by 2 because I'm converting to base 2. If I was converting to base 8, I could do this same procedure. All right. How many times does 2 go into 23? 11? And there's a remainder of 1. Guess what we're going to do with that remainder of 1? We are going to push it. We're going to push it. 2 goes into 11 5 times with a remainder of 1. We're going to push it. 2 goes into 5 2 times with another remainder of 1. 2 goes into 2 1 time with a remainder of 0. And 2 goes into 1 0 times with a remainder of 1. So I push all the way. Now, if you've done this before, some of you are saying, well, there's a 16, there's no 8, 4, 2, and 1. A 16, and then no 8, a 4, a 2, and a 1. So you kind of have an idea of what's going on. So now that I pushed, I'm going to pop and build a string. Pop 1, pop 0, pop 1, pop 1, pop 1, and I've just converted to base 2. So I've done division and modulus, division and modulus, division and modulus. I did something like I have a number, it's 23. I said number equals number divided by 2, which now makes this that 11. Remainder equals num mod 2, and then I pushed remainder. And then I looped back around until my num became 0. Really? Yuppers. What do you think about that? Should we try another one? If I wanted to do base 8, what is 114 base 8? Excuse me, base 10 converted to base 8. Well, I have my 114. 8 goes into it 14 times with a remainder of 2. Push the 2. 8 goes into 14 one time with a remainder of 6. Push the 6. 8 goes into 1 0 times with a remainder of 1. And now I pop. 1, pop. 6, pop. 2. And there's my answer. How do you like that? A 64, 6 8s, and 2 1s. Right? So what I want you to do now is you should have on D2L code samples chapter 7. And give me 1 second. I'm going to pull it up as well. Back to Zoom. I'm going to Zoom and I'm going to share. Converting from base 10 to base 2. Here's an example of what we've been talking about. Enter a positive number. While the number is not equal to 0, check it out. I get the remainder and I push the remainder. Then I did integer division and I kept looping around. When I was done, I came down here and I did pop and print, pop and print, pop and print, pop and print. This guy uses stack.h. Gaddis called it int stack. Here they're using just stack. And if you come down, you can see that here is the header file. We come down and see what's going on in here. We have the push and the pop. Here is the implementation file. Gives us an array of size 128. Cool. Cut, paste, loaded, and run. Cut, paste, loaded, and run. Again, this is the NIOF book. He just calls it stack. Gaddis called it int stack. You're converting to base 2. I see 2 numbers in there that need to be changed if I wanted it to go to a different base, like 8, not 16, because we don't have A's and E's and all that right now. Check it out now, Funk Soul Brothers. That's a pretty cool implementation. This book is almost 20 years old, but I still like it. Hopefully you enjoy it as well. Thumbs up when you get it to work. Base 10 to base 2. That was pretty darn slick and quick. Oh, your head's shaking. Yes. I'm guessing you're getting it.
It works for me.
Good. Hey, does it work for you?
Yep.
Which
Cool.
program was it again?
Was the converting from base 10 to base 2. It was on that HTML code chapter 7 NIOF that I gave you on D2L. So a nice little application there of converting from base 10 to another base. I like it. Adam, you good?
Yeah, I'm good, thanks.
Okay. Nicodemus, you're good. Emily's good. Yep. Okay. Back to me. Next thing we're going to do is another application for stacks. We have 15 minutes. I mean, this is a busy class. Um, this is something that later is going to become really important, this concept. So it's actually good to bring it up now. There is a blah blah blah. Just go with that for there's things that are going to happen where we take a traditional expression like 6 + 4 and we say the operator is inside. We call it infix. Well, there's a way that if we start to change this up, we can have computers solve big expressions. Okay. And in order to do that, we need to change this thing of infix instead of the operator being inside to postfix. What was on the left side of the plus? What was on the left side? What was on the right side of the plus? And then that actual operator, okay, the actual plus. So it's going to look something like this to be postfix. And yes, there's something called prefix where the operator comes before it. Okay. So if I come up to this first one, again, I had this what was on the left, what was on the right, and the plus, but now I have more than one operator. All right. Well, which operator gets done first? The multiplication or the addition?
Multiplication.
Yeah, order of operation says the multiplication. So we're going to do it first. We're going to say A, B times. Because when I do that A, B times, that sort of becomes its own unique thing. That sort of becomes its own unique thing. This is converted. So now this guy is the left of the plus. So I took care of the times. I said left, right, and then the operator. Now when I come to the plus, I'm saying the left, which is that whole thing, the right, which is C, followed by the operator, plus. And what's going to happen with the Q is we're going to do something along the lines of this in a little bit. Push the A, push the B, Uh-oh, we see an operator. That means we're going to pop, pop, solve. Push the C. We see the operator. We're going to pop, pop, and solve. So instead of variables, we're going to actually put numbers in. We would push the 6, push the 4, pop the 6, pop the 4, add them together, push the 10. It's the way that we can have the computer do it. This guy says, uh-oh, do this first. B, C plus. So it becomes its own little thing. Took care of the plus. Come to the multiplication. Do the left, which is A. Do the right, which is B plus C. Do the multiplication. Interesting. Very, very interesting. All right. Whoa. Let's see how the computer would do this. I'm going to do some numbers here. 4 plus 2 times 8 divided by parentheses 6 minus 4 parentheses. So if I type this as an infix statement, we're going to get in a couple minutes here a program that says, wait a minute, I can take this and convert it to postfix. When I convert it to postfix, the parentheses are going to be gone, but I'm going to maintain order of operations. Once that's gone and I get it written in postfix, I can say, hey, stack, solve that for me. What? I know, right? So let's see what's going on. This looks like its own little thing, right? 4, 2 plus. Here's this guy's own little thing. 6, 4 minus. Here's division. I'm going to do the left, the right, and then division. The left, the right, and then the division. Here's multiplication. Here's the left, which is all of this. Here's the right, which is all of this. And I'm going to throw the asterisk out on the end. So let's see if I do the math. This is 6. I did that first. This is 2. 8 divided by 2 gives me 4. 6 times 4. My answer should be 24. My answer should be 24. Ooh. So there's a program that I'm giving you in a minute that's written that will change this into this. It's going to eliminate the parentheses and it's going to build this nice guy. That would be hard to write. You're close to where you could be given enough time, you could write it. Now, once I have it written in postfix, I'm going to do a push of a 4. I'm going to do a push of a 2. I'm going to say, uh-oh, here's an operator. Pop the 4, pop the 2, add them, and I put in a 6. There's a number, 8, push, push, push. Uh-oh, I'm running out of room here. So now I'm sitting on 4, 6, 8, 6. The 2 went and the 4 went. Okay. I just pushed that minus. I'm going to, I need to be careful. When I pop, this 4 has to be the right side. So I pop the 4 to the right. I pop this, excuse me. I pop the 4, it goes to the right. I pop the 6, it goes to the left. I subtract them, and now I push a 2. I did the 6, 4. It says, uh-oh, go back and pop and pop. Now I hit division. I'm going to pop the 2. That's got to be on the left. I'm going to pop the 8. That's going to be on the right. I get a 4, and I push that back on. I get a times. Pop the 4, that's on the right. Well, I got rid of that 8. Pop the 6, that's on the left. Multiply them, and I get an answer of 24. Once I get the answer, I push it back on. Ooh. Ooh. Questions. There's a lot to digest, but you have, whenever you have your second meeting of the week to take care of that, I'm going to go share. I'm going to come in and stack and stack. I didn't go share, did I? I'm going to go share. Here we go. Now we're sharing. So we had stack and stack. Okay. We come in and we had an implementation for it. So, and a test program. Now you notice what NIOF calls the linked list one. D stack for dynamic stack. Push and popper over there. Lots of good stuff going on. Here's the implementation file. Lots of stuff. Man, oh man, oh man, oh man. Okay. Test program. Okay, we've always seen demo programs, but here's what I want to get down to is and some more stuff. Driver for that. Here you go. Converting infix to postfix. I gave you an example. We did one with a parenthesis 4+2 and so on and so on. And check out all the cases. What do we do if it's a left parenthesis, a right parenthesis, an add, a multiply, and so forth? We're doing lots of operations here. Again, this one uses dstack. It's using the linked list version, but it's a way to convert from infix to postfix. Now, if I come down, now I should be able to, once it's in the postfix, be able to get it to pushes and pops. But this guy's pretty cool right here, converting infix to postfix. Okay. Something bad. Look at this line right here. This is a for loop that runs. No, you can do better than that. But did you ever see a for loop that looks like that? Okay. So your job, and this is on your own, this is your own self-discipline, is to get this converting infix to postfix up and running so that you can go ahead and do the calculations for it. We're not going to take time in class here, but this is all time that you get by us not having a second class to practice all of these things. Put stuff up on the discussion board. Hey, I'm stuck. Did anybody else get it to work? Tell me what I'm doing wrong. You guys have to work together, you folks. Instead of me sitting here watching you. This is what the school wants us to do. Push for this.